In this lesson, we're going to go through several business applications that involve quadratic functions. For the profit function below, find the number of units that gives the maximum profit and then give the maximum profit. So whenever we're talking about the maximum or the minimum and we have a quadratic function, what we're really looking for is the vertex. So remember, in order to find the vertex, we need to find the x value first and then plug that value into the function to get the y value. So remember that the first coefficient is a, the second coefficient is b, and the third coefficient is the constant c. To find the x value of the vertex, the formula is x equals negative b over 2a. So here we have x is equal to negative 300 divided by 2 times negative 0.1. When we simplify that fraction, we get an x value of 1,500. The profit, if there are 1,500 units, would be plugging it back into this function here. So when I find that value, when I compute that, I get $223,800. So that means that there's a maximum profit of $223,800, and that's obtained when 1,500 units are produced and sold. In our next example, we're going to continue with the same profit function, but now we want to find any break-even points. So there are several ways that we can find the break-even points. Remember, the break-even points are when the profit function are set equal to 0. So when I have a quadratic function set equal to 0, the two common ways that we can find what the roots or the zeros are of the quadratic function are by either factoring or using the quadratic formula. There are a couple other ways that we can do it, but those are usually the most common ways. Well, this function I'm not going to want to try and factor because of that negative 0.1 as our first coefficient. That's not going to make it easy for us. So let's go right to the quadratic formula. So just a reminder, x is equal to negative b plus or minus the square root of b squared minus 4ac, and that entire thing is divided by 2 times a. So here I have x is equal to negative 300 plus or minus the square root of 300 squared minus 4 times negative 0.1 times negative 1,200. And that entire thing is going to be divided by 2 times negative 0.1. When I type this expression in the calculator, I really try to do it into several steps. The first thing I do is I calculate what that radicand is. So that's 300 squared minus 4 times negative 0.1 times negative 1,200. Okay, from there, we can then try to find out what the numerator is. So because it's negative 300 plus or minus the square root, I'm going to find the positive version first. You could also find out what that denominator is, just to save yourself a step. So we have negative 300 plus the square root of 89,520, and then we're going to divide that number by negative 0.2. So one of my answers, one of my break-evens here is x equals 4.0053. Now we're going to do the same thing for the second solution. I have negative 300 minus the square root of 89,520. And I'm going to divide that by negative 0.2. So I have another break-even at 2,995.9947. So the two places where the profit is going to be zero, where we're going to break even, is when about 4 units are sold, and again when about 2,996 units are sold. In a monopoly market, the revenue of a company is restricted by the demand for the product. So that means that the revenue is going to be the product price times the demand. So our product price is going to be P, and our demand is going to be X, because that's how many units that are going to be demanded. Suppose that in a monopoly market, the total cost per week of producing a high-tech product is given by that function, and the demand function is P equals 500 minus 2x. Find the number of units that will give the break-even for the product. So we know when we're given cost that we need to have revenue in order to find the break-even, in order to find where the profit's going to be zero. So since we're not given the revenue and we're in a monopoly market, we need to find the revenue. So our product price here is 500 minus 2x. Our demand is going to be x units. So that can be simplified to be 500x minus 2x squared. In order to find the break-even points, we're going to set the revenue and the cost functions equal to each other. As I said earlier, the only way that we can find our solutions to a quadratic function or a quadratic equation is by getting that equation equal to zero. So that means moving all of the terms from one side to another. So I'm going to move everything from this side over to the right. So we're going to get 0 is equal to, the 3600 is going to stay the same, minus 400x plus 4x squared. Again, you have really two main options to solve a quadratic equation. You're either going to try to factor it or you're going to use the quadratic formula. This is actually going to be pretty easy to factor. The first thing we want to do is factor out the common factor of 4, because we see that 4 goes into each one of those coefficients. At the same time, I'm also going to rewrite it in descending order to help us factor it. And then all we're left with is factoring the x squared minus 100x plus 900. That's going to factor into x minus 90 times x minus 10. Since 90 and 10 are going to multiply to positive 900, and negative 90 minus 10 are going to add up to negative 100. Ran out of room, so I'm just going to move up to the top here. We then use our zero product rule to find what the values of x are. And we find that x is equal to 90 or x is equal to 10. So that means that there are two different number of units that's going to create a profit of 0. That's when 90 units are sold and produced and 10 units are sold and produced. In this example, we're going to look at a demand and supply function. If the demand function for a commodity is given by P times Q plus 4 equals 400, and the supply function is given by 2P minus Q minus 38 is equal to 0, we want to find the market equilibrium. Well, we know that in order to find the market equilibrium, we're solving a system of equations. We're solving the demand and supply equations simultaneously. So my system here is P times Q plus 4 is equal to 400, and 2P minus Q minus 38 is equal to 0. So you could decide whether you want to solve this by substitution or elimination. It really doesn't matter which way you want to solve it. I'm going to solve it by substitution because I think it's a little bit easier. I'm going to solve this bottom equation for Q. So I get Q is equal to 2P minus 38. And I'm going to substitute that into the top equation. So P times 2P minus 38 plus 4 is equal to 400. I'm going to combine like terms and distribute all at once. 2P squared minus negative 38 plus 4 is going to be a negative 34. And that's equal to 400. Remember, whenever we solve a quadratic equation, we need to be equal to 0. So I'm going to subtract that 400 over. In this case, I'm just going to use the quadratic formula. And when I use the quadratic formula, I get two possible answers. I get that P could be negative 7.5367, or P is equal to 26.537. Well, since we're talking about the price and the quantity, we know that the price can't be negative, so we can't use that negative value. So the price here would be about $26.54. That makes the quantity about 15.08.